Okay, so we're trying to graph our point P first, which is 296, and then we're going to graph Q on the same plane, which is for -1, -5. Okay, so I already drew my axes. I have my Z that's vertical, my X and Y, which are going to form a 90-degree angle. So now I'm going to go ahead and label my X. So this would be 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, -5. Okay, so I'm just kind of putting those slanted as well to show the flat level. This kind of looks like the old school antennas that they would put on top of TVs. Do you guys know anything about those? Yeah. Okay, and then for Y, 1, 2, 3, 4, 5, 6, 8, 9. 3, 4, 6, 7, 6. Okay, so for P, I'm going to start here at the origin at 0, 0. And then I'm going to go 2 along the x-axis. Okay, so first I'm going to go 2. Then I'm going to go out to 9. Okay, and really your line is going to be like slanted out to 9. And then just like we talked about our Q box on the board, if I want to go somewhere, and for this one it'll be at 6, I'm not going to go all the way up to 6. What I'm going to do is I'm going to go a little bit in front of it, because if this is where 6 is, when you're putting that out, when you think of that in 3D, it's going to be a slanted line that's going to go towards the 6. So really, your point P in space is going to be right here. Because just like the cube, it's going to be slightly slanted. Yeah, George?
So that line has to be parallel to Y. So in essence, like every line that you draw up there is going to be parallel to another line that's already there on the grid.
Yes.
Okay.
Yes. Okay, good. Other questions for me? Do you guys understand what I'm saying about this part here? Like why it's not all the way up to 6? Okay, because again, it's when you're drawing in 3D, you kind of have a slanted motion. So if this were on a flat surface, then this would be lifted up. Okay, so we're just going to do a little bit. Okay, and now we're going to do Q. Now with Q, first we're going out 4. And then we're going back 1. So I'm going back 1 here. Now just like before on my cube when I was drawing like dashed lines to show you what it would look like if it was behind there. If it is behind, then usually you will like dash to show what it is, to show that it is directly behind there. And then this would go directly to -5, but a little bit above. So like this line, this part would be dashed, and that would be your Q. And for that one, it was -5, right? I'm just gonna even my points out a little here. 2, 3, 4.
On our homework, are you gonna give us like paper that has this plane already drawn out? Or do you
No,
have to draw it?
no, you draw it. And that will be towards your -5. What's that? No, you don't have to do that. I just do it to give you a better visual. Okay, and then that's our step 1. Now for step 2, it says we have to use the distance formula. Did you guys see where the distance formula was for this? It was at the bottom of your paper. And really, it's like the same distance formula we know and love, but now our z-coordinates getting in on the action here. So for your distance formula, you're going to subtract your 2 x-coordinates. So I would have 4 minus 2 squared, -1 minus 9 squared, and -5 minus 6 squared. So 4 minus 2 is 2. What's 2 squared? 4. -1 minus 9 is -10. That squared will be 100. And then -11 squared will be good. Okay, now if it's not exact, you can round it to the nearest hundredth. This one is exact. So your answer will be 15. Okay, so that will be your distance between P and Q. All right, let's try the next one. Do you guys want to try it by yourself first? Think about it. So we have -3, -1, -4 for P, and Q is 3, 1, 4. So we're going to start here. And then I'm going to draw my X and my Y. Okay, so for my x-coordinates, I have to make sure I can go to -3 and 3, 1 and -1 for my y, and then 4 and -4 for my z. So I'm going to space these out a little bit more. So 1, 2, 3. And then 1, 2, 3. Extend that. 2, 4.
This is weird.
It is different. Okay, so for the first one, we're going to go over -3. Okay, so we're going to start at 0, and then we're going to go back to -3. Now we're going to -1, which means we're going to go back here. And then remember how I said, like, if it's behind, you can show that it's behind by doing the dashed line. And for our z-coordinate, I want to go to -4. So just think about, just keep in mind, actually, maybe I'll do this in pencil first. So I'm going to make that dashed. And then my line should be so that this over is going to represent your -4. So I'm just going to dash this to show, hey, this is going behind the plane. And And that would be our point P. Yes.
Why is the rest of it, like a straight line, not a dotted line, if it's still behind?
That, well, I just do it because it's, if you're looking at it, like this part is behind this segment.
Right.
So if there's no segment in front of it, then I don't put the dash line.
Okay.
Does that make sense?
Yeah.
Okay. And then, yeah, Abby?
So won't all of our graphs look a little bit different depending on the angle that we start with in our axes?
Well, the only thing that'll be a little bit different is like you can space out your tick marks a little bit more, but generally your angle between them is going to be similar. So like you're always going to have like the try here. But yeah, I mean they aren't all going to be exactly the same, but they'll be at the coordinate on your graph.
Yeah.
Yeah. Yep. Ethan?
For the slant with the z-axis, is it right to think of it as before you add the z coordinate, the same angle that's between that dot and the origin is the angle that you'll use between the point P and the desired point?
Will you say again that angle?
The point between P and -4, and the line between P and -4 is the same angle as point X, Y, and like the origin, right?
Oh, like this one here? Yes.
The other one, with the X and the Y. Above the dot.
Oh, with this? Yes,
Yeah.
because it would be like a box,
Okay.
like a cube if you connected. Like this would be your top part of the cube.
Okay.
Okay, and then so we're gonna go 3 on the X for that one, and then the Y. So my Y is a +1, so I'm gonna go out 1. And then I'm going up 4. And again, remember I'm stopping a little bit in front of that 4. That's my Q. Yeah. Yeah, did you guys see what Ethan was asking me?
Yeah.
So like if I were to connect this line here, this would be the same angle. And then it would be like a 3D box, a 3D prism. Yep, Abby.
What would point P look like if it was positive 4 instead of negative 4?
If it was +4 instead of
Yeah.
-4, it would be just like this one, just like Q. See how we did positive, negative, negative?
Yeah.
So if this was positive, negative, negative, it would be here,
So what if it
then
was
you go
negative,
back.
negative, positive?
Oh, okay, then it would just be straight up from here,
Okay.
and it would still be like slanted, but you would just go up to about here.
Okay.
Okay, and then we're gonna find the distance. Actually, did most of you already do that?
Yeah.
Okay, so your distance for step 2. Okay, if you subtract 3 minus -3, it's really 3 plus 3 squared. And then 1 minus -1 is really 1 plus 1 squared. 4 minus -4 is going to be plus 4. I just put the minus and negative to show you what that's going to be. So 6 squared is 36, 2 squared is 4, and 64. So then you'll get the square root of 104, and that you can round to 10.20. Okay. So you don't have any homework tonight, I guess, unless you want to start your homework. But then tomorrow we'll finish the back, and then you guys will have some time in class to work on your homework, and then put 9.3 on your homework log. And then once you put 9.3 on your homework log, that's the whole first page. Okay, so you're not putting the review sheet on your homework log.